Welcome everyone. My name is Naresh Kamboju. Today I'm here to talk about LKFT, uh, the Linux kernel functional testing, why it's so important in our Linux kernel community. Before I start, I would like to know how many of kernel developers here? Any? Oh, 1, 2, 3, 4, 5, 6. Okay, great. Maintainers? Yeah, great. One. Got it. So the main audience that I'm trying to from kernel developers and testers. So I would like to know. That's the reason. So let's move on. We'll talk about our LKFT. So why it matters and how it's been evolved. So I'll go quickly. Like since we have been testing from couple of years, so on LKFT point of view. So the Linux kernel is everywhere in terms of the tiny IoT devices to supercomputers. So it's running everywhere. The ARM hardware is vast and there are multiple vendors and there is a probability of getting frequent updates and there is a probability of high risk of breaking things. So that's the reason we have to test Linux kernel. So the LKFT has been here to have infrastructure ready that we have been doing every day and day out test, nightly test and commit by test. So what we are doing here is like we are focusing mostly on ARM64 hardware and as well as virtual platforms to ensure the stability of Linux kernel. How we are doing it? So it's impossible to do manually. So our infrastructure has been evolved like Lava and Tux currently we have and the dashboard. So with the help of all the automation infrastructure, we're able to achieve this. So what are the components that we are involved in automation and the process of detecting bugs? So we'll get into that. As well as like why we have to do and what is the importance of it. So since it's kind of a long-term stability validation, so we have been into LTS validation continuously from stable RC point of view. So it's been a kind of a successful project and we have been maintaining the stability of LTS kernel. So in next 20 minutes I will be talking about the why kernel testing is critical and what is the role of LKFT here and what are the platforms we have been covering. So what are the platforms we would like to cover if somebody is interested to add their SOC to the board, so that would be good. And what are the test suites available? So currently we have a list of test suites that I'm going to describe. So if you have any inputs on like what are the test suite that you would like to recommend, add or missing, so we are happy to take your comments in. We'll talk about infrastructure. Just now on the previous session, Senthil has mentioned how Tux suite and the Tux mix are been helping LKFT project in a way. So that's a tremendous way that because we are been doing a parallel testing so on the cloud, which is helping LKFT in a scale. Special kernels. So we have been doing general testing, but since we have been announcing the results out and the maintainers and kernel developers have suggested to use extra kconfigs and finding out Kasan and few more 64, 60K, 16K page size, 64K page size, multiple extra kernel configurations and extra tool chains from a better coverage point of view. So I'll be covering that as well. So what are the active branches and mainly and reporting regressions and bisections. So how our tools are being developed to detect the regressions early and sending out the reports as well as bisections processes. So there are a couple of bisections in terms of boot and test. So this is mostly an interactive session. So stop me anytime if you want. We'll deep dive into it. So kernel testing. So why it's critical? So we know why it's critical, right? So it's pretty known because in the world of ARM there are multiple vendors and the multiple hardwares. It's running on most of the devices. So it's our duty to make sure whenever we do an upgrade or stabilizing the kernel, we must have to do a certification done in terms of testing the functionality and making sure that the tests are passed. If there is a regression, then we have to make sure that that regression happens all the time and we have to report such a way that it's like an intermittent issue or a always reproducible issue. So these are the things that we have to make sure and we have to give a kind of confidence to the maintainer saying that this particular code works, this particular subsystem works. We have validated X, Y, Z number of test suits and it works. So that's the reason we have to make sure and give a confidence to the maintainers and the code base that it works. So that's about this slide. Making sure that ARM ecosystem is running a Linux kernel. So what is LKFT? So LKFT is a process and a framework which involves multiple tools. So the primary focus is validate the Linux kernel, but how and way. So the first thing is like triggers. We have a GitLab triggers. So we'll be covering that. Basically, we have to go with the build test first, as we are using tux suits and tux mix to do the builds. So this is pretty helpful. So we do the builds. So once the build is passed, we go for the boot test. Once the boot test is passed, we go for a running of test suits, that is mostly LKFT, kselftest and kvm-unit. So there is a list of tests, and these tests will be running on a real hardware which are being connected to Lava and the cloud. Currently we are, Linaro is working on LLA to get this thing better, as well as we are running an FEP virtual platforms from ARM. So this is a process of getting the regressions and identifies like it's like a known issue or it's a new regression, making sure you have enough data around it and sending it out with the details, when it started, where it's been happening, is it specific to SOC or a particular hardware or not. So these are the information we'll be adding into the regressions. So when we report regressions out, right, so we'll get to see some emails back saying that this is a patch, give it a try. So this may fix. So, and the couple kind of questions what we get, like what are the kconfigs that you're using to reproduce this issue. So these are the information that has been there. So LKFT is combination of all these things to make developers' life easy and the maintainers' life easy, and vendors will have a confidence that their resources works. So the infrastructure is like this. So GitLab, I don't know where it is going. GitLab will do a trigger. So we have a mirrors over here on Linux mainline on the next trees, and we have a stable and stable RC mirrors, and we'll wait for a triggers and the tags releases or Greg pushes announcement. Accordingly, it will give it a trigger from GitLab, and we are having a set of rules, that is tux plan rules. We have a tux plan YAML files which are being maintained from LKFT. So those are being submitted into tuxsuit. So tuxsuit takes that as a plans and it builds with the tux mix on the cloud. So if the build pass, we have a storage available, and the storage have all the artifacts available. So we'll go for the boot test. If the build fail, and we'll be running like hundreds of builds every single plan. So out of 100 builds or more than 100 builds, so we'll get to see the stats. So if the build fails, and we'll get a notification saying that this particular build got failed. Then I had to go through the details of it, like is it a new build failure or is it a older one, it's a known issue or not. If it is failing, like is it failing because of toolchain issue, or it's because of kernel issue, is it because of DDB broken or a kernel broken. So these are the things I had to validate manually, and the data is available in the squad, so it's pretty easy to identify most of the regressions from build point of view. The HEY is also available live now. Live now, we will talk about HEY in the other sessions coming up. These are the dashboards, basically squad and HEY. So these will give you a clear picture of where it's got started and when it started, the complete metadata around the squad and HEY. So we'll give you clear dashboards of is it a known issue or not. So accordingly, I'll generate a report with the clear details of if it is a build failure, we have a link and the details of tux make or a tux suit command, so that if you want to build this particular same build reproducer, so you can do and it, because most of the people do not have their own installed tool chains on their machine. So it's kind of a little pain for them to go and download the tool chains and build it. So tuxsuit and the tuxmix are the APIs and the tools that are being solving this problem of the build reproducing is easy. So those steps also been included into the reports. And as well as like this particular kernel build failed with 64K page size. I can clearly say that, this is the specific case with 64K page size. Then uh, the maintainers will look into it. Oh, this is particular special case, then they will come back and say, okay, there's a problem, and the particular patch which has been released for 4K page size in my mind, in their mind, but it's been broken for 64K. So there is a way they will come back and send a patch to me saying that, hey Naresh, try this patch. I think whatever the report that you have sent, I'm gonna fix this issue. So if the build pass, so we have a tux test and tux run, so that will use a LLE and lab in general. So the labs are located in Cambridge, or you can have your own local or a vendor-based remote labs, so that the test will be done on the real hardware as well. So there are tests running on FEP and QEMUs. So that will be done in this block of things. So once the results are available, the results will be pushed back to squad. So squad will and he will do is like it will compare from the previous good and the current the latest build, and it will compare how many tests got pass and fail. So it will give you a clear list of number of recent failures and the number of recent failure fixes. So accordingly, like myself and my team will look into the generating a report and sending it to the maintainers and Greg and Sasha. So this diagram clearly shows how multiple building blocks are available to do our job. This is basically an infrastructure way, so that's a diagrammatical way. So this one I would like to talk about is here. So this is kind of a regression tool that is being developed recently in Linaro, where we are mainly focusing on known issues. So known issues is like a real pain, really a pain, because a particular test case is unique, but it has multiple dimensions of. It could be passing with the X toolchain version, but it could be failed with the Y toolchain version. That same test case name is passed with one K config and it failed with other config, and the same test case can pass on multiple ARM64 devices and it could fail on a specific ARM64 device. Then it's not easy to identify which test case is failing for which device or which tool chain, which K config. So these are the multi-dimensional way of looking into your test failures to identify the real reason behind of it. So to make it short, the known issues, we are maintaining a list of known issues and having a clarity of why we are marking this as a known issue. Is it real regression, or is it like in progress regression? Is it like not supported? So these are the multiple tags that we are trying to add to make sure everybody understand in a better way when we do a regression identification and reporting it. So we have a good number of test coverage overall. If you look at the number of devices that we have from Samsung, ARM, Qualcomm, and open devices. So TI also. So from ARM we have a Juno and a Dragon Board 410C and 845C from Qualcomm, WinLink E85096 boards from Samsung, Raspberry Pi, Raspberry Pi, BeagleBoard X15 from TI. These are pretty good test coverage what we have in functional testing. If you look at the Baremetals and VMs, so Ampere and Graviton 4, so this is we have been getting a very good results from server point of view from Graviton and Ampere. So they are like very quick in terms of running the test and giving the results. So we are able to identify a couple of regressions on this test one. I mean build one. While booting, there are a couple of regressions. While testing, a couple of regressions like test regressions, boot regressions has been identified on Graviton and Ampere. So we are happy to say that our efforts have been acknowledged. For virtual platform, so FEP from ARM, so we have been having a best coverage of FEP from ARM and from QEMU. So QEMU has multiple options to validate as well. So these are the platforms we are covering. So if you have any suggestions that we are missing from test coverage, so I'm happy to get your feedback so that we can add. So current Ben is team is saying that LKFT is running Pixel now, so that he's going to announce in his own session. So, but just giving you that is also kind of one of the hardwares that we are trying to discover. So if you have any new devices or new servers, please. Yeah, so these are the number of test suites. So same question, I guess, like these are a list of tests for functionality, for virtualization, for kernel logics, for better functionality tests for LTP. So you know LTP syscalls, schedulers, heap groups, IPC, math, LTP. So these are all the functional tests that we have been running, and we are able to catch regressions, and we are able to send it out with the reason for it, and we done a lot of bisection to identify a real regression. And the good thing is that we are, as LKFT team, so we have been sending out regressions very quickly. We are trying to give a better from our LKFT point of in time to get the regressions out as soon as possible when we see it, and report it. Make sure that we have enough infrastructure and sending out a bisection out. So whenever there's a patch coming from maintainer saying that this is a patch, you could go and give a try, or you can revert this patch and give a try, then we are pretty actively in terms of talking to maintainers and making sure that the life cycle of the bug is shorter. So we don't want to see the same bug prolonging for months and months. So it's not a great idea. So that's the reason we had to come up with a known issues list. So device tree, KUnit, kvm-unit for virtualization, kselftest is a self-test from kernel functionality test, LTP, libhuge TLB pages. This is for huge page tables, and GPIOD. This is for utility for GPIO test cases. So perf test, it's a part of kernel. So performance counters, RC torture. So it runs as a part of read copy update from the boot test. So we can do a like RCU self torture test. Then it will do that. XFS. So this is pretty interesting, and we are able to catch a couple of XFS issues also in the file system. So we are happy to run this list of test cases. So I'm super happy. If you have any ideas of adding a new test case, so you're most welcome to give a hint, so that accordingly we'll see how long it's going to take and how many devices we could cover on that particular device probably. Yeah, go ahead, please.
Do you want questions now or at the end?
Pardon?
Do you prefer questions now or at the end?
No.
I'm curious about your torture testing and stress testing. In our experience, Ampere, with high core counts, we tend to find these tests. So with high core counts, we find that some of the stress tests, especially on ARM64, trigger soft lockups fairly common. It's one of the most often reported things that we are debugging on the kernel team. I'm curious what your experience has been with these tests, and if you have a way to sort of manage those soft lockups that are kind of either known issues or just how often it happens for you.
Dan, do you want to cover? Okay. Yeah. So RCU torture test. So we have been running, and I have been continuously validating these results. And not in the recent past, but a couple of months back, I sent regressions to Paul Muckney on the regressions we have seen, like soft locks basically. So, and there are a couple of there are a couple of deadlocks issue also has been found. So yeah, so that's kind of a coverage we able to find. Like out of couple of months, we'll find only 4 or 5 RC, soft lock works. Yeah.
I feel like Ampere, your systems tend to be have more CPUs than ours. Ours are more mobile focused.
Yeah.
Until now, so.
So you have them now.
Yeah.
Well, soon. We'll talk about that outside of the room.
So it's not something we've seen a lot of.
Okay. Hopefully you see more of.
Yeah.
So the cost of finding a single bug is pretty expensive. So, but it's worth to find one bug and report it as soon as possible, so that it won't get into the stable RC. So, yeah. Any other questions? So, yeah.
Sorry.
Do you want a mic?
No, I'm fine as well. I'll try to speak loudly. Just curious, what are you testing perf tests? That like PMU events are being read correctly?
Yeah, the default PMU event, yes.
Okay.
Like start, record, those things. Yeah. So do you recommend any special flags to be added?
Not at the moment.
Okay.
Just joined, but working with performance optimization sometimes.
Yeah.
Thank you.
Yeah. We can have one-to-one if you want to. Yeah. Thank you.
Is it on the edge devices only, or you do also servers testing?
Ampere Ultra that we have one, and the Graviton. Rest of them are like developer boards. We been running from Graviton 3 and Graviton 4 now, so and Ampere Ultra mostly. Do you have any specific use cases that are specific to server side testing that we are missing?
I was thinking that actually, like how you do some of this hardware stuff, which is in GPRD, would be very platform specific, right?
Yeah.
So, and then how do you scale it? Whereas in server, maybe it's not so much of importance.
You're right. You're right.
That's the experts. So probably we can talk offline. How do you scale it?
Exactly. So we have, that's a good question. I appreciate that. So we have test plans in our repository. So those are been designed in such a way that which has to run on which device, which hardware. So if you look at huge TLBFS are meant for that, and kvm-unit-tests are meant for that. So KVM, I mean, there are ARM64 feature testing from kselftest under the kselftest. So they do specifically ARM v8, v9 kind of a specific test coverage. So those are the things are being drafted in test plans. So this particular test plan is for Graviton, this test plan is for Ampere, this test plan is for X device. So those are the things. Yeah, moving on to that, we Andish has recently made a preempt.t enable in our test plan. So this has been a very successful run. So from 6/12 onwards, we have been testing this. So we are happy. So any real-time testing, so we are happy to cover that in a way. These are the special configs. 64K page size, 16K pages size is been requested by Google. So they asked us to do a better test coverage in the recent past. Then we started running it. So it's been a great finding. So I have a list of test cases which are been specific failing on 16K page size, 64K page size, and 4K page size. So I have a list of things. So I have been debugging it, and I'm talking to our developers to identify the real reasons for it. So probably we'll be sending out a list of the issues that we have found and fixed. So Kasan is also a pretty good way of validating, and it's been giving a good sanitization for us. So we are able to get a better coverage from that. So same thing with device tree. So device tree has been enabled from a booting point of view. So it's a self-test from boot. We are running that as well. So from toolchain, so we have a good coverage from Clang 20 and Clang nightly, as well as like GCC 13 and GCC 8, because that's the lowest coverage that we are trying to see from GCC 8 and currently GCC 13. So we are able to find multiple bugs on Clang and Clang nightly. We have a better coverage from Clang as well. Yeah, these are all made possible because of Tux has been providing our life easy with all toolchain supports. If you look at the last quarter, these are the starts. So what we have done and how much we have done. These are just numbers that will give, but it will give you a real work and the regression count and the number of bells that we have done. So it's pretty impressive in a way, but we would like to scale up much. So it's good that we found 50 regressions out of 151 release candidates from LTS itself. There's a long-term stable kernel RC. We have a agreement of 100% of reporting those regressions in 48 hours of time. The Greg pushes in his email saying that please respond before 48 hours of time if you find any regressions. If it is not, then it's too late. He will be releasing the tag and he will move on to the next release. So that's the reason we had to gear up with our release cycles and make sure that the team is available and the infrastructure is available to get the results done and the reports done and send the reports out to Greg. So that's the LTS part of it. from Linux Next and the mainline, it's the best efforts of making sure that we are finding the regressions early and reporting them early, so that whenever I report something to Greg, and he will come back and ask me like, is it happening on the vanilla kernel? Is it happening on like Torvalds kernel? Yes or no? Then if I say yes, then it's like, okay, no problem. So it's broken on mainline and it will break here. But that will be like having a lower link of thread, which we have been discussing. So he will be looking into it, and it's like he will follow up on those people saying that this particular things has been passed to stable, then it's time to fix it, or you can just drop the patches which are been problematic. If you look at the current last 6 months of total, we have done 593 kernel revision builds and 262 thousands of kernel builds, and they have been tested with the multiple other test suites that we have been listing out. So if you look at the test count, it's more than 81 million. So it's too much of testing. Yeah, it's a large test data. Yeah. The branches that just now we covered about mainline, we test mainline master branch from Linux Next. It's a daily tag that has been released, and we do test every Linux Next tag from Linux Next. So Sasha has requested recently that he would like to add his Linux Next kind of a new tree. So that has been added to LKFT test plans, and we are running that master branch. From Linux stable RC, yeah, this is a continuous effort of maintaining LTS test validations to Greg and Sasha. So these are the branches and the tests. So reporting lifecycle. So what are the things that we involve is like we generally report the bugs as possible, and we identify the bisections. We run the bisections and identify the bad commits. Yep. Oh, we're done. Okay. Okay. Yep. The main agenda is that be transparent and the results are available. So Linux is publishing the results openly, so it's available and you can go and take a look on the dashboards, and it's a kind of a collaboration project. Yep. This is one of the examples of regressions how we have found and reported. So in the single stable RC review, we got to select 1, 2, 3 regressions. So one of them is on kvm-64 and FEP, where we are running a self-test ARM64, and we got to see a kernel warning. So that's a ARM64 mem copy issue. So this has been reported. On the same stable RC, we have seen one more kernel warning on the Graviton V4. So this is found at the time of booting. So this has been also included. So on the other hand, we have a LTP FS. So this has been running on kvm-64. We found one more file system buffer issue. So this also been reported in this lower link. So you can take a look if you really. So how report look like? This is how the report looks like. 1, 2, 3, 4. Like I'll be adding details of stack trace. So it's not just a stack trace. So in Linaro we have a LKFT project. So that completely goes with the decoding of stack dump, and after the decoding only we will be sending out these codes and the file names and the line numbers. That will give a better picture to the developers and the maintainers to identify where exactly it's got failed by using the call trace. So that's a good thing we have been doing. So it's helping them. Yeah. So this is a Clang issue that I'm just trying to identify. So this Clang has a better coverage from our point of view as LKFT. So these are been boot failures, just not a build failures of a Clang. So the build was passed, but the boot regressions have been identified on RuckPy, DragonBoard 410C, and DragonBoard 845C. So there is no console output, there is no kernel panic or no issue, but just blank. So these are the things that it's not easy to, identify in a reporting point of view. So these are how the report look like. So we'll say like where it started, which commit ID, which Git describe, and what are the devices it's been happening, what is the good and bad Git describes, and what are the devices has been happening, which boot, which tool chain. So is it reproducible or not? So is it a new regression or not? We'll talk about like which devices it's been happening. So we'll just say like reported by with our signing off there, like reported by LKFT. And there is no console output, but the interesting part here is this one. kernel versions and git tree, git sha, git describe, project details, architecture where it's been happening, the number of tool chains, kconfigs, so LTO thing and hardening LTO full, and build docs. So builder, I mean the kernel developers can directly jump here and they see like which kconfigs and the artifacts, the history of it. So this is pretty useful for to reproduce and investigate and do it. So that's the way we are helping out the kernel community in a way. So what we are doing is like we are sending out the emails and reports, and we are continuously communicating with kernel maintainers and SOC subsystem developers and getting the feedback, continuously saying that testing their own patches and fix patches and trying to add their own kconfigs and giving it a try. Yeah. So the summary is that LKFT is helping the Linux quality across ARM ecosystem. So, and as well as it's pretty critical for LTS because we have been continuously reporting multiple regressions. Like if you look at recent past, it's a 50 plus regressions and 150 releases. So mainline stability as well. So we are running really powerful test tools on a real hardware to identify the issues. So it's best efforts of developing Linux kernel community as well. Yep, done. Thank you. Bye bye. I'm just on time. Okay. Thank you.